Customers are looking for help. Help in choosing the right products to use in an upgrade. To do that, you need to understand how lighting affects their work environment. The good news is that you don't need to be an expert. Just understand 8 basic terms, and you'll be able to ask the right questions and provide the right answers. In this module, we cover input watts and lumens. So let's talk about input watts. What exactly is an input watt? Technically, all 3 answers are correct. We will focus on number 3 because that is what is most important to your customer. When calculating input watts, there are 4 main types of light sources. First, we look at incandescent and their close cousin, halogen. These lamps run on line voltage and don't need a ballast or driver. This means that the lamps use whatever the lamp rating is. A 60-watt lamp uses 60 input watts. The next group of lamps require a ballast to operate. These include fluorescent, metal halide, high pressure sodium, and low pressure sodium. If there's a ballast involved, then input watts are higher than lamp watts. An example is 400 watt metal halide. The lamp is rated at 400 watts, but the actual input watts is 455. An exception is T8 lamps. If they're using an efficient electronic ballast, then the input watts can actually be lower than the lamp watts. Compact fluorescent lamps have a built-in ballast, so the lamp watts is equal to the fixture watts. LED products don't use lamps. What you have are LED chips that are powered by a driver. Because of this, each LED item is considered a complete fixture, so the input watts and the rating is the same. For example, if you put 10 LED lamps in the candelabra, then you have to treat it as 10 mini fixtures in a housing. So the components of LED products are the power source, there's a driver, there's the LED chip itself, it could be a single or an array of chips, there's a heat sink to get rid of the heat, and then often a diffuser or lens to control the direction of the light. Input watts are important as they help determine what your energy costs will be. You multiply the input watts of the fixture by the annual hours the fixture is on, then divide by 1000, and you get your yearly kilowatt hour usage. Multiply that by your kilowatt hour rate, and you get how much it costs yearly to run that individual fixture. Here are some examples comparing different fixtures. The more watts the fixture uses, the more it costs you in energy. While there are many benefits to a lighting upgrade, saving money on energy is the one most customers and people focus on. To save money, you need to reduce the total input watts used by your customer. And there are 3 common ways to do that. So option number 1 is to use more efficient fixtures. In this example, if we reduce the input watts by 16%, we can save $515 a year. Option 2, we add occupancy sensors or timers to turn the lights off when not necessary. If we can reduce the hours the lights are on by 9 hours per week, we increase the savings from $515 to $916 for a net of 29% energy savings. The third option is to add dimming. If 30% of the time the lights are on, we can reduce it down to like a 50% light level. We can increase the savings to over $1,200 a year for a net savings of 39%. When deciding which customers to focus on, the longer the hours the lights are on, the greater the potential benefits. So let's look at some of the benefits of reducing input watts. I mean, everybody understands lower energy costs. The longer lights are on, the more potential savings. For example, if your lights are on 6 hours a week, each input watt you save is 35 cents a year. If they're like an exterior fixture where they're on 12 hours a day, 7 days a week, that goes up to 50 cents a year per input watt. And if you have a company where the lights are on 24/7, you can save them $1 for every input watt you save. Not everybody pays the same for their energy. The more they pay, the more the savings. For example, if instead of 11 cents per kilowatt, they're paying 15 cents per kilowatt, their savings go up from 35 cents to 48 cents, or 50 cents to 68 cents, or $1 a year to $1.36. Another benefit is reduced load. If you reduce the watts, you reduce the amps. So you can either add items to that circuit or eliminate the expense of building brand new panels. The third main benefit is the environment. Creating energy has an impact. Hydropower is considered clean as it's low emission, but you still have the impact of a dam and the hydro lines. Coal generates much more greenhouse gas than hydro, so there's a higher effect on emissions. A big target from both a cost and environment aspect are those remote communities that use diesel or gas to power their generators. Some of the questions you want to ask end users are, do they know how much they spend on lighting right now? Energy costs aren't going to be getting any lower in the future. Could the money they save on lighting, either from a maintenance or energy costs point of view, be used somewhere else? Profits? More staff? New equipment? Could they use more capacity on certain circuits? Upgrading to LED? Maybe they don't need to add panels or circuits. And is being more environmentally responsible important to your company? Lower electricity use means less greenhouse gases created, less demand for power. And will a green image benefit the company? Here is a list of available videos. We're in the process of upgrading these, and we're releasing new versions in the coming months. In addition, we can provide training certificates for your company programs. Thanks for taking the time to watch this. Our goal is to make your interaction with customers more productive for both parties. Understanding lighting terms and the question to ask will help with that.